Okay, before we go on any further, let's just make sure that you understand these A-B diagrams and these colored diagrams, and then of course the examples. So I've printed this out for you here. Here we have the A-B form and how the reaction works. Here I have the colored diagram, and then over here I have some examples, okay? So it was getting hard to read for me there in the beginning. Now you can do it over again, but I'm just going to go through this. These are the AB formats on how the reactions work. In the colored diagrams, A is usually in red and B is in blue. We have A plus B make our AB over here. Or it would be as if this was N2 and this was H2, and here I have NH3. Alright, so the diagram represents what's going on in the reaction. I'll do one more. In our our decomposition reaction right here, I have AB that breaks up to form A plus B. I would also have H2O, which would break up into hydrogen and oxygen gas. And so these are just some examples of different ways to display and teach and show and for you to learn the mechanisms of how these reactions rearrange themselves. On to the analogies. Let's pretend you're about to go to prom, and some of you are. One way that we use to describe the mechanism of how the reactions work is through a dance. So here I have my little jitterbugs, my little dancing guys, and when you look at these 4 different types of dancing scenarios, you can see how we could relate this to a chemical reaction. So here my little guy right here, my little A guy and B guy, they're going to get together and party and dance, and we call that a synthesis. Sometimes couples at prom break up. That's actually B, isn't it? And we call that a decomposition. And they go on to dance by themselves. There's always some lonely guy who's gone stag at prom. And sometimes he gets lucky and he can exchange out places for that guy and he can have a new date. And A and C can party and B goes on to be by himself. It is like a swap or a swing dance where you change your partners. Sometimes you can change your partners all the way around. You can have one couple and another couple, and they go into the dance, into the chemical reaction, and they come out having completely rearranged their couples. They're backwards in this picture, by the way. And just to give you a visual of, this is really how the reactions work. I mean, if this guy is one element and that guy is another element, and we have an element and a polyatomic ion, for example, in a reaction, they can switch partners. That's how they transform into something else. So what is it called when both couples exchange partners? What do we call that in the South? We call that a do-si-do, right? I don't know. Anywho, moving on, you have a types of chemical reactions practice. And in these following examples, you will need to determine what type of reaction that they are, honestly, just based by looking at them. I'm going to do a couple with you here. Here I have a single compound that breaks up into many, and we call that a decomposition. The next one, I have a compound, and oh look, it uses oxygen, and it forms and transforms into CO2 and water. This part right here, in the presence of oxygen, it makes CO2 and water, is what lets me know that this is a combustion reaction, and not a double replacement reaction. So those are oftentimes confused with students. Believe it or not, they have the hardest time picking out combustion reactions. So you should go through these following examples and see if you can determine what type of reaction they are. Another part is just based on the first two reactants, can you determine what the products are going to be? So in 11 through 20, I've given you examples of just the reactants. And you're going to have to identify what type of reaction it's going to be without knowing what the products are. And this is often very challenging. The easiest thing for you to do is to kind of first look at it and determine if it has one thing on the left-hand side of the arrow. If there's just one thing, the chances are is that it's a decomposition, right? Because nothing else forms that pattern. Anytime you see something that's going to use oxygen in the presence of some sort of hydrocarbons, that is, chances are that's going to be combustion. And those are usually the second easiest ones to see. Now, without going too much further, the third easiest one to find is a single replacement. A single replacement can be easier because it's usually a lonely metal all by himself. See how aluminum is all by himself there? And then the next two are, that's the dancing pair, and that's the lonely guy. So we're going to have a single replacement reaction right there. So I'm going to give you some time here to see if you can go through the rest of these and determine what the type of reaction is. Good luck!